Dear viewers, welcome to another video in the series of outlier analysis. In this video, we will understand about the third statistical technique or method, which is called Dixon's test, in terms of identifying whether your given data have outliers or not. Let's get into the video. As we saw in our previous explanations about using z-score as a technique of identifying whether the data have outliers or not, you calculate z-score, and based on the z-score you apply a 2 standard deviation rule or a 3 standard deviation rule, and based on that you decide whether the data have outlier or not. And then we also saw how the Grubbs method works, where we calculate the z-score, then convert it into G calculated, and from there we calculated the G critical, which is from the table, compared the G calculated and G critical, and decided whether the data have outliers or not. Now we'll see the third method, which is called the Dixon test. So Dixon's test is basically to see what is the gap between your suspected outlier value from its nearest value. The first thing that we need to do is we need to identify how far is your suspected outlier value from its nearest value. So that's the first thing that we need to do, calculate. And once we calculate that, then we will also calculate the range of your overall data, which is maximum minus minimum. Then we will have something called Q calculated value, Q table value, and then we will make a decision from the calculated value to the table value. That means if your Q calculated value is a bigger number compared to your Q table value, then we will declare it as an outlier. If not, it's not an outlier. So this is the process used in Dixon's test. So let's see how does it work. So here I take 8 as a suspected outlier value. Similarly, I take 3 as a suspected outlier value because these are extreme high and extreme low values. Now what I do, I calculate the gap. How do I calculate the gap? The gap here will be my suspected outlier value minus my nearest value. So 7.06 is the nearest value. Similarly, here my suspected outlier value will be 3. So in here what happens is we need to use the reverse option. So it should be 4.76 minus 3. So it should be 4.76 minus 3. So this is the gap. So this is the distance between my suspected outlier value and its nearest value. So 8 minus 7.06, and in this case it will be 4.76 minus 3. Now what I need to do, I need to calculate the range, and for range we all know the formula, which is maximum of the given data point minus minimum. So maximum minus minimum of the given data point. Right, so here the range is 5. So same will be the range here. So I just say is equal to. Now I need to come for the Q calculated value. So Q calculated value will be is equal to what is my gap divided by what is my range. So this is 0.188. And similarly here, what is my gap divided by what is my range, and this is 0.352. Now we need to go to the table where we have the Dixon's standard values, which we call it as the table value, Q table value. So I have the table value downloaded in the PDF format. If you want a copy of this Excel file or the table value, like how I told before, I will share the email address in the description. You can write to us. We'll be able to share the table value for you. So here is the table value. Now how do you need to find out the table value? Here my number of data points is 30. So my n is equal to 30. So what we need to do, we need to go to the table, and here I am looking for a 95% confidence level. So here is my 95% confidence level, and the table value for n is equal to 30 with 95% confidence level is 0.2594. So what I do here, I come here and I type 0.2594. So this is the table value, 0.2594. 0.2594 is the table value for 95% confidence, and n is equal to 30. So 0.2594, right? So the same value will be the value here also, 0.2594. So here my condition is this. So here I will write if the formula is if calculated, that is, so if q calculated is greater than q table, then call it a outlier, right? Else call it not a outlier. And here 8 is not an outlier by the Dixon's Q test, whereas 3 is an outlier because the Q calculated value is 0.352 and the Q table value is 0.2594. And if I come back to the table, and if you see this table, as I explained previously using the Grubbs test also, the table values will actually, if you see here, the table values will be a bigger value here for the n is equal to a smaller number. As your n is increasing here, the table value will become a smaller and smaller value. So that is what we need to understand. So this method is also not my preferred method. My preferred method for a data which is normally distributed, now we have seen all the three methods, which is extreme z-score value, where you take a 2 standard deviation rule and 3 standard deviation rule, and you have a Grubbs method, and you also have a Dixon's outlier method. For me, Grubbs method is what I generally prefer using when I want to identify the outlier for data which is normally distributed. Friends, I hope this video was useful for you to understand the Dixon test, Q test to identify the outliers. So in my previous videos, I have explained about the other test, which is the Z-score test as well as the Grubbs test. The link of those videos will also be shared in the description. So if you want to have a look at it, please have a look at it. Then you can decide and choose whichever test you want to use. Thanks for your time. Thanks for watching this video. In my upcoming video, I'll be explaining about the IQR method, which is generally used for data which is not normally distributed. So thanks for watching this video. Have a nice day.